So, log properties. I'm going to write 3 of them down for you, and one of them we already know, so it's going to be super easy. The first one is if you are condensing I guess the first 2 are if you're condensing two logarithmic functions together. So if I've got log of A, we're just going to call it A, and it could be anything, plus log of B. The way to combine those 2 would be log of A times B. So they'd be multiplied together. So if you've got a plus sign, that means multiplication. And it can be any base down here. No, the bases have to be the same. So if it were like log base 2 of 5 plus log base 3 of 5, those would not combine together.
Log base 2. Okay.
Like the bases need to be the same.
So what about number 2?
We're going to get there, Graham. I know you're excited, but we've just got to just hold our horses here. So let's make a note that they have to be the same base. Number 2. Now, if I have log base A minus log base B. Ooh, yeah, you do. Log of A over B.
And that would be with the same base.
Yeah, all of these are same base.
Is the base 10?
It doesn't matter what it is. It could be 2, 10. It could be natural log. It could be any of that. And then the third one is one that you already know because we talked about it in 8.3. But if you have log of x or anything to a power, what do you do with that power? You bring it out front. So it's like n times log of x.
Okay, so when you do this, do you mean log base 10 x to n?
It can have any base.
Yeah, but it has to have a base. The base can't be x. Because log
Can
base
you do like
x
number?
n would be.
Can you put?
It can be any number. Like it could be 5
Can you
or
put, I was literally thinking 5.
it could be anything. I hesitate to put a 5 there because I don't want you to get caught up and it has to be a 5 because it doesn't. It could be anything.
I'm gonna put an n for number. Oh darn!
There's already put an A there. We're running out of letters.
I think
There's
it's
26
okay.
letters.
Okay, we can put an A there. But it can also be the natural log. It can be anything.
So wait, why is there that?
So basically this is just coming out front.
Okay, would you put parentheses around log ax?
You don't have to.
So like, what would you would find log ax and then multiply it by n.
Uh-huh.
So can I put parentheses? So I don't
Sure, if you would like to. Here's something that I guarantee you somebody in here is going to miss.
Me. All of us.
No. Okay, here is what is going to happen. And I'm going to tell you right now that it's going to happen.
Are we gonna kill
God, I
puppies?
forgot.
And this is killing a puppy right here. So I'm going to give you a question and I'm going to say true or false.
No.
I'm going to say log A plus log B equals log A plus B. Is that correct?
No.
No, that's silly, right?
False.
And I'm going to say log A minus log B equals log. You say that, you would be like, why would I get that wrong? That's so easy. Of course those aren't right. But somebody's going to do it. I just know. I know. It happens. It happens every year. So are we vowing right now that nobody's going to do that in here?
I can't do that.
We must write it on the board.
I'll get a paper. Actually.
David, if you're watching this, you cannot make this mistake because the class feels like you're going to be the one that's going to make the mistake.
I just
Wow.
wrote your name in the box already, but just anticipating that this is just what's going to happen.
You guys are
But I believe in you, David. I think that you're going to rise above the occasion and you're not going to make this mistake. Okay, we're going to move on. So,
Now's the video pause.
terrible.
no, it's not pause. So, here we go. We're going to do some evaluating of the expressions.
That's a lot of numbers.
I'm going to erase these mistakes because they're kind of just hurting me a little bit inside.
And she wants us to forget.
Okay, so I'm going to combine these, and I've got a plus and I've got a minus, okay? So the pluses will be multiplied, and the minuses will go on the denominator. So, and you always look at the sign that precedes the log, and that's where it goes. So if you have a minus before it, then it goes to the denominator. If it has a plus in front of it, then it goes to the numerator, okay? So you can even write that down if you want to.
Okay.
So if it has a plus in front of it, it goes to the top. If it's got a minus in front of it, it goes to the bottom. It gets divided, okay? So to combine all of these, they all have the same base. So I've got log base 2. On the top, I have 6 times 20. And then on the bottom, I have what? 15. Now, I want to evaluate this. So 6 times 20 divided by 15. 8. So I've got log base 2 of 8. And what does that equal? 3. Oh, how easily we forget these things.
Yeah, for real.
Yeah, I don't know.
Because how do you get from 2 to 8? You raise it to what power? The third. So that's why it's 3.
So basically, whenever you have like the little thingy and the big thingy,
You think, how do you get from little to big?
thingy?
That's it. You just explained logs in a sentence.
I don't get big to little. That's the thing. Like,
That's
that
the one that throws me.
That's a
that's
fraction. It's a
It's a
fraction.
So basically, it's the same thing, but you just put like it's like 1 over something.
Mhm.
Yeah.
That's funny.
Okay, now let's look at number 2. Which ones can I combine?
Wait, you can combine the ones with the little twos.
You can combine these two, but I can't do anything with this guy right now. So I'm going to leave him by himself.
Or
We could simplify.
But I can simplify him by doing what?
squaring him.
No, this has this exponent guy.
Move the 100 in the front.
Move the 100 in the front.
Okay, now is the 100
Log.
just do that remember the log 416?
Yeah, it's like, here's my parentheses. It's like 100 times
Okay.
this. Plus, how do I combine the log base 2?
Log 2,
6 times 2/3. Okay, so let's keep simplifying.
I'm confused why it's in parentheses.
I'm multiplying them. You don't have to do parentheses. Sometimes I just add parentheses. What is log base 4 of 16? Like, what is this? 2. So 100 times 2, which is 200, plus log base 2. What is 6 times 2/3?
That's
4. So then I've got 200 plus 2, which is 202.
Wow.
Nice.
Oh my gosh.
That wasn't bad.
Oh my gosh.
All right, now I'm going to do what we call condensing and expanding. Okay? So condensing means I've got them now all separated. I want to put them together into one log function. Okay? So I'm really just looking at the pluses and the minuses. And I have 3 separate natural log functions. Okay, so what goes on the top and then what goes on the bottom?
The first one and the second one go on the top.
Okay, so I'm just going to put a big LN right here. It's big. And on the top are the first and the second one. So I have A plus B, A minus B. And what goes on the bottom?
2.
C.
C. And what does that 2 in front mean?
That means that
I need to like
that's
undo
exponent.
it. Need to like undo it. So it's like saying C squared. Can I simplify the top any more? What is A plus B, A minus B?
Wait,
No.
No, it's 0.
Isn't it just
C squared again?
Wait.
The 2 in front
Yes.
means it's an exponent. It's like undoing the property, essentially.
I thought you can't.
I thought you had a multiplier.
I thought you can't like simplify it if it's different and they're in
I can multiply them.
So
So do
2a
you
or
FOIL
a
it out?
squared.
Yeah, how do I FOIL this out? What does it look like?
A
A
squared.
squared plus 2ab.
No. FOIL it out.
Hold on.
A squared minus AB plus AB minus B squared. What does that become?
A squared plus b squared
over c.
equals
A squared plus B squared?
minus.
Minus. It's a difference of 2 squares.
Wait, why is this?
I don't like this.
I see.
That was what's
Okay. So when you're doing these, and maybe I should have said this earlier, but sometimes doing the exponent first makes more sense, and then I condense. So, for instance, these are my exponents, the 2, or the 1/2, the 2, and the 1/2. I'm going to go ahead and raise those, or bring those up.
Wait, so that was the final answer?
So it would look like, yeah, that was my final answer on 3. So it would look like log square root of x plus 1 minus log of x squared plus, what's the square root of x squared?
X.
So it would just be log of x. Because I did the square root of x squared.
So we don't use the numbers in front anymore?
No, because I've now raised them to I undid that power rule. So if there's a number in front, it's like saying that log to that power, whatever the number in front is. So I just took all of the numbers in front and I undid the power rule where I raised them to the power. So I raised this to the 1/2, I squared this, and I raised this to the 1/2.
Wait, it's a negative. No, it's not. I'm just.
And raising anything to the 1/2 is like doing what? Square rooting it. So I square rooted the first and the last one, and then I squared the middle one. Now I want to combine them. So what goes on top?
Log of x.
The log of x. And what else goes on top?
The square root of
Square root of x plus 1. What goes on the bottom?
x squared.
X squared. Can I simplify this any more?
Yes, x squared minus x, the first power. You can get rid of the x on the top, the isolated x.
Okay, so x over x squared reduces to just x on the bottom. So my final answer would just be log square root of x plus 1 over x.
I'm so confused. Why does log square root of x plus 1 go on top?
Because it has a plus in front. I mean, it's basically like a positive. Understood plus. It's not, if it's not negative in front, then it stays on top.
So it's not like you're looking at. You're not looking at 2 of them and looking at the negative sign to be like, oh, okay, so that means these 2 are dividing. You're
Mhm.
looking at just the 1.
Like the sign in front. Okay, let's look at the last 2.
I'm ready to take a nap.
So now I want to expand. I want to expand. So right now I'm going to circle all of my variables. I've got x, I've got y, and I have a. So I'm going to separate it into 3 separate log functions. And you're going to separate the numbers too. So if I had a number, I would separate that as well.
Wait, couldn't it theoretically be log e, log base e x squared
Uh-huh.
y minus log base e square root of a?
Right, but you want to separate the x and the y.
Okay.
So you want to separate x and y and a.
Okay.
So here, like when you're expanding, you want to separate the variables and also numbers. So if I had like a 2 in front, like if it were 2x squared y over square root of a, I would now have 4 log functions. The 2, the x squared, the y, and the a.
Okay.
So you separate numbers and variables. But let's just do number 5. So if I'm separating it, it's going to look like natural log of x squared plus natural log of y minus natural log of square root of a.
That's it.
That's not it.
You got it.
You got to do the powers.
Yeah.
So now I've got to fix the powers. So I have a power here and I have a power here. You like my little...
How do we know that we have power? Confused on
What?
what is square root of a.
I circled the powers.
What about it?
So instead of saying square root of a, it's like saying a to the what power? Good. So now I'm going to move those out front. So it looks like 2 ln x plus ln y minus 1/2 ln a.
I see something like
Okay, there's 2 ways that you can do number 6. You can go ahead and apply the 5 to the x and the y if you want. So it would be like ln x to the 5th, y to the 5th. Or, and this is my personal preference, bring the 5 out first,
even front A.
then separate. That's my personal preference. So how do I separate the x and the y?
Isn't it plus?
Uh-huh.
Plus ln y.
Good.